Right.
All right, so we're going to take our coordinate plane that we're very used to seeing, and we're going to put degrees around it like we've done on a protractor, okay? So this should be familiar to you. You always work counterclockwise. So if this is 0 degrees, up here would be your 90 degree. What would be over here? 180 degrees. We can keep going. So what would be down here? 270. And if you make one complete circle, you have now gone to where? 360. Okay? So what the wonderful mathematicians did is they created angles on this quadrant, on these quadrants, okay? So they would put the vertex of the angle right at the origin, and they'd create a ray, and this, they would call this the initial side. And then they'd move that angle around, so they'd, you know, here, 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 like that, around it. So I'll land like right here. We'll say this 150 degrees. This would be your terminal side. Terminal meaning where it stops, where it ends, okay? The angle that it created is theta. Okay, we've seen theta before. That's what it is. That's the angle created, theta. This right here, this angle is known to be in what's called standard position of an angle. And I do want you to write that definition down because a lot of other definitions come from this definition. So standard position of an angle. And that's my symbol for angle. The standard position for an angle is exactly what I just described. It's an angle that has been positioned so that the vertex is at the origin and the initial side is along the positive x-axis. An angle positioned so that the vertex is at the origin and the initial side is along the positive x-axis. So your first part of homework tonight is going to be really easy. There's 3 things that I'm teaching you today. You're going to draw, you're going to convert, and you're going to find something called a coterminal. That's it. That's all we're doing today. 3 things. Okay? Drawing, let's start there. You need to draw angles. And I want you to remember, if you are a positive angle, you go counterclockwise. But if you are a negative angle, you go clockwise. So let me give you 2 examples here. Let's do 225 degrees. Let's do 690 degrees. And then we'll do one over here, actually. We'll do negative 210 degrees. Actually, do a 4th one. Negative 450. Okay? So here's all I want. For you to draw 225, again, here's your, here's your axes. Where would 225 land? What quadrant? And here's 0, 90, 180, 270, back to 360. Where is it going to land? This is quadrant 3. If you don't remember your quadrants, it goes 1, 2, 3, 4. Okay? I don't need to see you draw the initial side. I don't need to see this. I don't even need to see the angle going around. I just need you to land in this quadrant. That's all I need. All I need you tonight is just to put where the correct quadrant it lands at. Why is that? Because there's going to come up things with that. We are going to learn about the signs of SIGN, the certain signs of certain trig angles. I will tell you though, if you do IXL, they will require you to make this angle like go around it, or if it goes around twice, they actually make you do a double loop. I know that some of the programs called Alex. There's a program at like CP, and I think UNCC has Alex also, and they make you do a double loop or a triple loop. I don't like that. I just need you to know where it lands. So then 690, where would that be? So let's see. If I go around one time, I'm at 360, right? If I go around two times, I'm at how much? 720. So if I start counting around, let's see, 360, 450, 540. Am I doing this right? 630. So where's 690 going to be? In that fourth quadrant. And again, I don't need you to be accurate. I do not need you to make the loops. Like, again, some people will make you go like that. I don't need that. I'm showing you that, but I don't need that. I just want this terminal side right here. That's all I need. Easy stuff, drawing. Let's do some negative ones real quick. Negative 210. So here's the difference with negative. So this is 0. Negative goes clockwise, so it goes this way. So this would be negative 90, negative 180, negative 270, et cetera, et cetera, et cetera. So where would negative 210 go? Quadrant 2. Negative 210 would be somewhere right there. All right, negative 450. So again, 0. One time around would be negative 360. Agreed? Then if I add another 90, now I'm at negative 450. Oh, so what do I do to draw that? You just actually, you land on the axis itself. Is that hard to do? That's literally the first like 8 questions of your homework tonight. Just draw, okay? And it may seem, again, you're like, oh, why do I have to do so many of these? But you have to get good at knowing where these angles are. It's so important, all right? All right, now, let me introduce you and talk to you about something also that the mathematicians of old developed. It's called the unit circle. So what they did was they took our coordinate grid and they created this circle that has a radius of 1. So this is 1 and this is 1, and obviously all the way around is 1. So if we're talking about plotting points right here, here, and here, this would be the coordinate 1, 0. This would be the coordinate 0, 1. This would be negative 1, 0, and this one would be 0, negative 1. Do you all agree to that, right? I'm a unit circle, unit meaning 1. So I have a radius of 1 going all the way around. Well, then they decided, hey, let's intercept this arc right here and make sure that this arc has a length of 1. And let's call it a new, entirely different new measure for an angle. Let's call it radian. And that's where radians come from. Now, you are not going to love radians because you're not used to radians. Radians is good. You like degrees, and I agree with you. I mean, I know what a 45 degree looks like right now. But right now in your head, you probably have no idea what a 3 pi over 4 looks like, but you will. So let me give you some little definitions here. A unit circle by definition is a circle of radius 1 whose center is at the origin of the coordinate system. Okay. You will develop more of a unit circle and its understanding when we get to that part, that section. You'll actually have to memorize the unit circle. Yay. Ask your friends in calculus how much they love it. But radians, again, so let me give you a definition for radian, because we love to have definitions here. We're kind of doing geometry, that's why. It is the measure of an angle. So you can measure an angle in degree. You can measure an angle in radian. Radian is used more often in calc. We use a lot of radians in calc. We barely use degree. But it's measure of an angle in standard position whose ray intercepts and arc length of 1. And so the formula that we use for radian, let's say formula, but how you convert 1 radian is equal to 180 degrees over pi. 1 radian is equivalent to 180 degrees over pi. So this is the second part of your homework tonight. You have to convert from degrees to radians, from radians to degrees, which I believe you did last year with Davis. If I'm correct. Am I correct? You did do that? Good. Just to refresh you though, let's go over these. Convert between degree and radian. And let me give you a few of these. 30 degrees, 100 degrees, 360 degrees, pi over 4, negative 3 pi over 2. Now, I don't like to give you like little tricks. I know the kids in the past have done it. I'll write it down for you anyway. Here's what I like to do. If they give me degrees and I want it to be radians, I want pi in my answer, meaning I want the pi on top. So this up here, I switch it, okay? If they give me radians and I want it in degrees, then I want the pi on the bottom because they can cross cancel out, okay? And then I'll be left with degrees. If you've done conversions with Mr. Risley, right? That's what we're doing. We're doing the dimensional analysis. If that doesn't make sense to you, then you can memorize this. To go from degree to radian, you multiply by pi over 180. To go from a radian to a degree, you multiply by the reciprocal of that, 180 over pi. So for this one right here, for 30, I'm going to multiply it by, I want radians, so I want the pi on top and the 180 on the bottom. And then you should know your fraction rules, okay? When you multiply, you are allowed to cross cancel. If you don't understand that, then you can multiply across and then reduce. But you should know how many times 30 goes into 180. You should know how many times 3 goes into 18. How many times does that work? 6. So the correct answer is pi over 6. Pi over 6 is equivalent to 30 degrees. All right, let's do this one. 100 degrees. Let's multiply by pi over 180. Okay. One of the zeros can cancel. How does 10 and over 18 reduce? What can go into 10 and what can go into 18 evenly? 5, 9, right? So it'd be 5 pi over 9. 5 and 9. All right, let's do 360. Multiply by pi over 180. The zeros can cancel. How many times does 18 go into 36? Twice. So your answer is 2 pi. I'm giving you some famous ones here too, by the way. I want to know you know how to do them. All right, now we've got radians, and now I want degrees. So now I want the pi's to cancel. I don't want pi's in my answer. So I'm going to put the pi on the bottom and the 180 on top. The pi's will cancel. And then, if you need a calculator, just do 180 divided by 4. 180 on top, divide by 4, 45 degrees. This one, same thing. I want the pi on the bottom. I want the 180 on the top. Pi's cancel. How many times does 2 go into 180? You should know that. 90. And then what's 90 times negative 3? Negative 270 degrees is your answer for that one. Negative 3 pi over 2 is the same as negative 270. Okay? All right, so first part, drawing angles. This is really hard homework tonight. This is like kindergarten stuff. Second part, converting between radians and degrees and radians. We can do this, okay? Last and final part is this idea, what's called coterminal angles. And this will be our last stuff for today. Yay! Okay. Do y'all know what the prefix co means? You should know what co is, like cooperative. It means together, actually. It means together. So if I am a terminal angle, we just found out what terminal means. That's where that end of the angle ends, or the angle ends at. And I'm in a coterminal. So here's what I mean. If I said to you, all right, everybody draw me a 45-degree angle right now, you'd be like, boom, 45. And I'm like, okay, draw me a 405-degree angle right now. And you'd go, okay, 360, and boom, 405. What did you just do? Coterminal. They're the same. Excellent. They're the same. 45 and 405 are the same exact angle on the quadrant planes. Okay, so what does that mean? These two are called coterminals. They're the same exact angle. Two angles in standard position that have the same terminal side. So on tonight's homework, I'm going to ask you to find me coterminal angles, two of them, one that's positive and one that's negative. Well, it's actually quite easy. How do I go from 45 to 405? What do I add? 360. How would you find a negative? Subtract 360. You add or subtract 360. That's all you have to do to find a coterminal. You add or subtract 360. Now, of course, it's a little bit more difficult when we do radians, and I'll do those in a minute. But let's just do some degrees and then we'll be done. Find a positive and a negative coterminal angle, or coterminal angles. Find positive and negative coterminal angles. So we'll do some degrees first. 240, negative 603. And then I'll do radians. Okay, so degrees is super, super simple. Okay, you take 240 and you go like this. Plus 360, boom, 600. There's a positive. You add 360. To find a negative one, take 240 minus 360, negative 120. Done. You add and subtract 360. Let's do that here. Negative 603 plus 360 is negative 243. Wait a second. How am I going to find a positive then? No. You just keep adding. You just add another 360 to find a positive. Oh, 117 is positive. You either keep adding 360 or you keep subtracting 360 to get a negative. So positive 117. I mean, you could have just kept adding 360 and given me 477. You'd be like, oh, well, I'm going to give you 477. Fine, whatever you want. Just give me one that's positive and one that's negative. Okay? All right, so that's really easy. So if it's degree, add, subtract 360. But what if it's radian? What are we going to add if it's radian? What pi?
360 over pi.
360 is what equivalent to in terms of pi? We just did it. 360 is 2 pi. You are going to add and subtract 2 pi. But here's a problem, and here's what shows me students who do or do not remember their fractions who really shouldn't be in this class. If I add 2 pi to pi over 4, what do I actually have to add? The denominators are not the same. I need to find a common denominator. So what is the common denominator of a pi over 4 and a 2 pi over 1? What do I really add? 8 pi. So I'm going to make you write this down because I made my other class do it too, and I think this will be helpful. 2 pi with a denominator of 4 is equivalent to 8 pi. Wouldn't you agree? 8 pi divided by 4, isn't that 2 pi? What if I had a denominator of 6? What would the numerator have to be? 12 pi. 12 divided by 6 is 2. What if I had a denominator of 3, which I'm about to have on that one? What would the top be? 6 pi. Do one more. What if I had a denominator of 5? What would the top be? Are you getting the picture here, right? So when you look at this one and you want to add 2 pi, what you really are doing is you're adding 8 pi's over 4. What does a negative pi over 4 and an 8 pi over 4 make? That is what I want as your positive. Now take away 8 pi over 4 to get the negative. What would that be? Good job. All right, let's do it to this one. I'm going to add 2 pi, but really I'm going to add 6 pi over 3, which would be 14 pi over 3. I'm going to take away 6 pi over 3. Ooh, 2 pi over 3, that's not negative. So what do I have to do again? Subtract another 6 pi over 3 to get negative 4 pi over, there's my negative. So hopefully that will help you out. All right, that's it today. That's all you have to do. Draw, add or subtract 360, multiply by pi over 180, and add or subtract 2 pi. So this should be easy, easy breezy stuff. Wouldn't you agree? All right, let me give you the worksheet. Yes, you have to do all of them. No, it's not busy work. I need you to know how to do this. You don't understand. I really don't kill you too much in here. When I ask you to do stuff like this, like where it seems redundant and seems repetitive, it's really to get it ingrained in your head. Honestly, that's all I'm doing. Right, Greg? That's what you want to know. Right? Colton? You can do it. No complaining. Okay? So for 1 through 6, I don't need the terminal part. I just need the terminal in the correct quadrant.